Okay, we have 2 minutes left. I want to do an example. I want to find the flux of the vector field F is zk through the sphere of radius 2 oriented outwards. It would take me 2 minutes to write down that D area thing for this, right? Yeah, like probably at least 2 minutes, especially if I'm going to try to say the whole thing. But I'm burning time right now because I can afford to, because I have this new toy. What's my new toy? Divergence theorem. So the divergence theorem says that if I've got an integral over some surface of a vector field, the area, right? This is a flux, which is the thing I'm trying to find here, right? I can trade that for what? Yeah, a triple integral. So let me just say an integral over, what am I going to be integrating over? Yeah, so I was integrating around the sphere, right? The outside.
And the volume.
And now I'm going to do a volume. So I'm going to integrate over a sphere, right? Of what? Divergence of F d volume. Okay. So what's the divergence of my vector field F?
Partials.
Okay, so I need to take my, I want to find divergence of F, right? So I take that nabla thing and dot it with F. So I'm looking for partial with respect to X, partial with respect to Y, partial with respect to Z, dotted with 0, 0, Z.
So just dz, dz.
So I get dz, dz out of this, right? Which is 1. Right? What's the change in z as you wiggle z? 1. Right? So I get out of this thing the integral over a sphere of 1 d volume.
Just the volume.
So that reads like the volume. So what's the volume of a sphere of radius 2? 4/3 pi 2 cubed. So yeah. Cool. That seems pretty chill, right? Okay, done. Could we have gotten the same thing the other way? Yeah, probably, eventually.
I know.
Would it probably still be trying to sort out that formula, right? So the divergence theorem here worked for us. Why?
This is continuous to piecewise.
Because we had a nice vector field, right? A nice surface bounding something I knew how to set up.
So it has to be closed, right?
Yeah, so this surface, right? This thing has to be the boundary of the region you're talking about. Could I have done this with the thing they asked me for in the previous problem where they asked for the flux through a hemisphere?
No. You can't take a piece.
Not even as a piecewise or flat.
So
sharp.
what I know from the hemisphere, right, is that the hemisphere is made of kind of a top half, right, which I wanted, and this bottom half that I don't give a crap about. You guys see that? I have no idea what's going on in the bottom half, and it's really going to mess up my day.
You would have to like do the whole shape and then subtract the float from the bottom.
Yeah, I could do the divergence theorem, the whole thing, and then work out this bit on the flat part and subtract it off, right? But that's not really going to be very convenient. Probably easier at that point just to kind of muddle through the horrible formula. You guys see that? So the divergence theorem has to be applied to the outside of a whole thing. You can't apply it to the outside of half of something. That kind of make sense?